slide, yeah.
Just the title slide, okay, and not your own face on
No.
your screen. Okay, perfect. And I'll leave it there. All right. Well, we are at 12:01, so I think we should get started. Welcome all. Hopefully others continue to stream in. We are here. I'm Christina Buck with Butte County Department of Water and Resource Conservation. I'm the Assistant Director. And this is a brown bag webinar. We'd like to do these periodically on different topics and record them and then post them later. So if folks don't catch it today, we will be able to make it available on our website. And we are fortunate enough to have Wolfy and Faith from the Butte County Resource Conservation District here today to tell us about the work that they've done as part of the park fire response and recovery. I'm gonna give us a little intro to kick us off and frame this up a little bit in a little bit broader context, and then we'll kick it to them to take over with the real content. So just want to remind us and kind of place us a little bit of where we're working. So the county, we work in 3 groundwater subbasins, Vina, Butte, and Wyandotte Creek. And there are groundwater sustainability agencies in each one of these subbasins, and sometimes more than one, that are each responsible for managing groundwater. And so that is really the task ahead. We were doing a lot of work in this space before 2014, but that's when the state law was passed that outlined kind of requirements and a framework around how local groundwater management should occur. So our approach as a department, and really the Vina Groundwater Sustainability Agency is taking this approach as well, is this kind of 4-prong approach to groundwater sustainability, thinking about how do we achieve sustainability or maintain sustainable conditions. And we're looking for opportunities to reduce water demand conservation or demand reduction strategies, looking to maximize surface water use. So where there are existing water supplies that could be used or expanded kind of in place or time, that would reduce our reliance on groundwater. That is helpful. Maximizing recharge opportunities. And we're going to talk about that one today more. And then really just through vision planning and partnerships. And this is something that our department has worked on really historically in partnering with agencies like the Resource Conservation District to advance these types of different opportunities and ideas. So when we talk about sustainability, we often kind of shift focus pretty quickly to the Vina Subbasin because that is a high priority subbasin as designated by the state. It's highly reliant on groundwater as a water supply, about 90% groundwater use, and only about 10% surface water. So you can see our desire to kind of expand that surface water side a little bit is part of the strategy. Groundwater levels have improved since the 2020-22 drought. Really kind of new historical lows in groundwater levels occurred in 2022 in some areas of the Vina Subbasin. But we got some relief with a wet year in 2023. Last year was a pretty nice average year, and even this year is looking decent as well. And so water levels have come up a bit since those drought levels, but we still see this long-term decline in groundwater levels and correspondingly in our estimates of groundwater storage, which is what this graph, very colorful, kind of different water year types are shown in the different colors. And then this dotted line starting in 2000 and goes in this case to 2023, the dotted line shows our estimate of groundwater storage. And so you can see how it gets some bumps in the wet years, but it has this longer decline. And so this is where action is needed in the Vina Subbasin to level off that decline and at least level it off, if not improve conditions in the subbasin. And so that's where we really want to, be proactive in these different approaches of reducing demand, looking for recharge opportunities, and expanding use of surface water when possible. So the Vina Groundwater Sustainability Agency received about was awarded about $5.5 million to do a number of different specific projects. And our department is taking the lead on portions of that grant funded work. And so this is kind of the breakdown of those different projects. You can see on the right side there, we're going to talk more today about what is called the Water Supply and Recharge Feasibility Project or study. We're also managing the effort for interbasin coordination analysis and modeling, and coordinating outreach program activities and administering the grant on behalf of the Groundwater Sustainability Agency. The Vina GSA is taking the lead on their own handful of projects, as you can see on the left side, and Becky Fairbanks in our office is managing a couple of these projects, including the data gap identification and data improvement project. That's really installing new monitoring wells and increasing our understanding of domestic well data and filling some of the data gaps that were identified in the groundwater sustainability plan. And then also the Lindo Channel Recharge Feasibility Study. And then the GSA has partnered with the agricultural groundwater users of Butte County to manage and carry out this project, demand reduction strategies, which is pursuing kind of two specific strategies related to decreasing agricultural groundwater demand. And then there's also a long-term fee study, which Dylan McGregor is managing on behalf of the GSA. So really lots of things going on. Different people are in the lead, but pretty exciting to be able to advance kind of all of these different prongs at the same time, and really at the end of this be able to have a better understanding of what are the costs, what are the opportunities and benefits, and what are kind of the key opportunities that should be pursued moving forward to narrow down our efforts and focus them a bit more. So again, today we are talking about maximizing recharge opportunities, and specifically this project and what Faith and Wolfy are going to talk about was one of the pilot projects that was funded kind of as part of this bigger water supply and recharge project. So this project has two components within itself. The first is to identify two most promising water supply projects. So again, looking for opportunities to use surface water in more places or more often when available. But what infrastructure would be needed to get it there? Who would that be? What would it take? So the idea is to identify kind of two most promising projects and complete feasibility analysis for those two. So that's the first piece. The second piece of the project is the recharge side and identifying potential places where we could enhance recharge and then conducting these pilot projects as possible. So really excited that the Resource Conservation District could help kind of make something happen this winter. So before we get to that, on the water, just to give you a quick update on kind of where the other tasks of this project are at. On the water supply side, the team did develop a list of project ideas, which this list is not new. It's a lot of the same ideas that have been kicked around by folks in our county for years. So that project list was completed. The Butte County Water Commission discussed those projects in December and identified 4 projects to kind of move forward that would get more information and analysis, a little deeper analysis. So that is happening right now. And then on April 2nd, just coming up, the Water Commission will discuss those 4 and recommend 2 of them to proceed kind of on to the next phase of level of analysis, which is the feasibility analysis. So that recommendation will go to the Butte County Board of Supervisors probably in May for final direction on those 2 projects, on which of those projects should have feasibility analysis. So then the second piece of that is recharge. The team has been developing a list of recharge sites using available data. There's lots of available data sets, especially for the valley area in terms of what areas might be conducive to recharge, and then thinking about landowners and who might be willing to explore opportunities. And so we've conducted some initial site visits and are gathering information on those recharge sites. And tomorrow at the Butte County Technical Advisory Committee, there will be a more detailed project update on this piece and more discussion there. So I invite you to check that out if you're able, or want to get this on your calendar, save the date for Sigma Grants Projects Panel, which is coming up on March 25th. And we're going to be talking about the recharge side, the water supply side, as well as the conservation side, and all 3 of those pieces. in one place and having the consultants kind of on a panel to present what has been happening so far and hear input and questions. So look for an email for registration for this event coming soon. I think it already went out through the newsletter for Vina, and our department will send out information as well. So with all of that kind of background, like I said, the water supply and recharge project, the recharge side, our goal is to do something, to try something with this grant funding through pilot projects and to do 1 or 2 if possible. And so the Resource Conservation District's efforts as they jumped into kind of post-park fire response was really a great opportunity for this project to just help support their bigger effort. And so that is our first pilot project. And then we're hoping to be able to do, as we're investigating these other potential recharge sites right now that are more further kind of west into the valley of the Vina Subbasin. Hopefully we'll also have a pilot project next winter. So with that, I'm going to turn it over to Wolfy and Faith to tell us more about the work that they were able to do this winter.
Well, thank you. Okay, yeah, thanks, Christina. Like she said, I'm Faith and this is Wolfy. Thank you for the support on this project. We're going to be talking a little bit about some of the post-park fire actions we took in the Big Chico Creek watershed. And so as we were starting to think about this project, we were thinking about what we felt the biggest threat to the landscape was going to be after the fire. And what we decided was that that threat was going to be post-fire erosion. As everyone knows, when a wildfire comes through the landscape, it removes that ground cover and that litter layer on the surface of the soil. And it really leaves the soil vulnerable and loose for erosion. And also you're losing that sort of surface roughness. So you're not having as much infiltration when you do have a rain event. And so looking at this map here, this is from the Park Fire Wirt Report. This is the debris flow hazard map. So you can see in the canyon, the hazard's quite high throughout. And then if you look towards the bottom, that thicker blue line is showing the Spring Run Chinook critical habitat. So with all of this in mind, we decided to really focus our efforts on keeping the sediment on the hill slopes and out of Big Chico Creek, and then also trying to help the water infiltrate back into the ground. And as we were planning this project, we got a really early rain event in August, and we don't know exactly where all of this sediment came from. It's likely that it probably came from some sort of mass wasting or landslide event up the canyon. But we do know that when Fish Bio went out to test this water with their turbidity meters, it was actually so high that they couldn't read it. So it was somewhere over 800 NTUs. And so this just really reaffirmed to us that what we were focusing on was the right thing and that we really wanted to get something done before the true rainy season started to try and keep as much sediment out of Big Chico Creek and on the hill slopes. And so we decided to form an incident management team with the 3 major landowners in the canyon. So this was the Big Chico Creek Ecological Reserve, the Higgins Ridge neighborhood, and then also the city of Chico. And the RCD was asked to serve as the plans lead. And together we decided that we wanted to build some process-based restoration structures with whatever materials were available post-fire. So burned wood and mostly rock. And then we created a technical advisory committee, or a TAC, and we took them into the field to look at the site and start discussing all of the nitty-gritty details of our design and really fine-tune it to go after our permits. And then after that, our GIS specialists, specifically Big Chico Creek Ecological Reserve, Tom Mello, did a lot of work to help us select our priority drainages, because we can't treat everything across the canyon, even though we would like to. So we picked all the drainages that we felt would help protect infrastructure and do the most work. And then we decided to plan our structures per 1 foot of fall, which is usually pretty standard for this type of work. And also, when you have that sort of redundancy, if you do have something happen to a structure, there's one right below it to catch it. So it helps just really with the integrity of the project and the design. And so with all of this, we came up with a sort of 3-pronged approach to restoration. The first part being to increase ground cover. So we know that if you can get your ground cover over 45%, you're reducing your erosion risk by 75%. And so some of the ways we did this were by contour felling trees and broadcasting as much chips and slash as we could. And then we also focused on our roads, as we know roads can be one of the biggest sources of sediment delivery. So we replaced all of the burned out culverts, we armored the critical dips, and we cleaned out all of the ditches. And then, of course, the process-based restoration. So we came up with this rock log hybrid leaky weir approach, and that's kind of what you're seeing in this picture here. These are Beaster crews putting together the weirs. And Wolfie, if you want to talk a little about the permitting.
Oh, I can talk a little bit about our permitting adventure. I don't know if we have some people who work in environmental compliance or have permitted projects in the past in the audience who will find this of any interest at all. If you do find this of any interest, I just know that I commiserate with you. And if you don't think this is interesting, then good for you. You're living your life right. But yeah, before I go on though, I want to talk a little bit about what process-based restoration is. Like we keep using this word, and in fact, I'll often just forget and say the acronym PBRs, which to us means the process-based restoration structures. So process-based restoration is a form of restoration that's usually pretty low tech, where you might put some gentle barriers in the face of a process such as runoff or gravity, and then allow that natural process such as runoff to slowly reshape the landscape. So instead of going in, if you wanted a channel to be reshaped, you could go in with bulldozers and you could really reshape it yourself, or you could maybe fell some trees into the water course and allow the process of runoff to reshape it itself. You might have heard of beaver dam analogs. That's a form of process-based restoration. So for short, we've been building all these structures up and down the canyon, and for short, we sometimes will just call them PBRs. Now, we're talking a lot about keeping sediment out of the creek, and I think most people can kind of see the benefit of that, but how does this impact groundwater recharge? I just want for people to, as we go through this talk, hold in their minds kind of a vision of the Big Chico Creek Canyon. We've all probably spent time there. You know how it's striated, like sort of a layer cake? You know, like there'll be a layer of where there'll be like a line of bigger trees and shrubs coming out of the canyon walls, and then there'll be kind of like a rocky layer, and then there'll be a layer with more vegetation, and then a rocky layer. That's the geologic legacy of all these different mud flows, some of them very porous, some of them impervious. So the porous ones, as you can imagine, are very good at storing water, or releasing and emitting water. They're porous to water. So that's where the springs and the seeps in the canyon are all coming out of the rock wall, and that's why you see all that vegetation there. So as we're building all of these PBRs or leaky weirs or whatever you want to call them, these structures up and down the tributaries to Big Chico Creek, some of these structures are being built across those porous layers. Those porous layers of rock essentially are functioning as perched aquifers. So when we can hold some rainwater on top of those perched aquifers for a little longer, even a few hours longer, or a few days longer, or a few weeks longer, some more of that water can percolate into that aquifer rather than run right off. And that means that some of those springs and seeps that we see coming out of the canyon wall, those can flow a little longer into the late spring, into the early summer, which, as you can imagine, is beneficial for all the creatures that use that canyon, and can spread out the duration of the flow of Big Chico Creek longer into the dry season, and that helps with downstream recharge as well. So now that I've given you a little bit of a break, I'll start talking about permitting again. The RCD, so me and Faith, and our district manager, that we were really in the position of acting as environmental compliance lead. We didn't go out there in the canyon and personally build any of these structures, but we handled the environmental compliance. So our first task immediately after the fire, kind of at that first meeting that we had, while the fire was still burning up north and the ashes were barely cooled down here, we realized we needed to handle California Environmental Quality Act compliance on this project. So since we already had our three-pronged strategy in place, like Faith mentioned, the RCD is able to function as a lead agency. So we filed a CEQA notice of exemption using the emergency that was in effect at that time on that entire three-pronged erosion control approach. And that NOE covered not only our actions, but the Big Chico Creek Ecological Reserve's actions. The Fire Safe Council was in the canyon doing a lot of like hazard tree felling and chipping and contour felling and good stuff like that. The city of Chico, of course, and also private adjacent neighbors who wanted to participate in the program. Faith mentioned that we really streamlined our thousands of sites in the canyon where it would probably arguably be beneficial to put a process-based restoration structure. We had a long list and we stripped that down to just the sites that directly kind of impinged on infrastructure. So the roads and the bridges in the canyon that people can use for evacuation. And that wasn't a decision that was really based in science or ecology. That was a decision that we made strategically in order to qualify for some emergency permits from the Army Corps of Engineers, which in turn opens up some useful compliance pathways through the water board and stuff. So the Army Corps just wouldn't necessarily give us a permit, even though it was an emergency, for sites that only had an ecological benefit or only had a recharge benefit. They also had to have a public safety benefit. So we just limited ourselves to those sites that had a public safety benefit, and there were plenty of them. There were still more than we could get to, so that wasn't such a big problem for us. And then we went ahead and also secured the necessary permits from the National Marine Fisheries Service, the U.S. Fish and Wildlife Service, CDFW. I want to say all of those wildlife-related agencies were exceptionally helpful and really understood immediately what an emergency this park fire was, and were really there for us in helping guide us through that system. Yeah, also the Central Valley Water Board too was great. Really helpful ally, and obviously like just very curious, thoughtful people who wanted to see if this would work or not. So once this permitting was in place, we made sure that each crew was accompanied by a GIS monitor who had a tablet and would record the precise location of every structure that was built, including before and after photos. So we're really grateful to the great team at the Big Chico Creek Ecological Reserve, especially Lindsay Amundsen is their overall crew lead, and Brianna, their forester, and too many others to name, who made sure that this data collection was happening every day. And in order to do so, they had to coordinate massive multi-crew workforce in the canyon. I think sometimes it was probably 60 or 70 people who were working in the canyon, and 4 or 5 crews from Upper Park in the south all the way up to like northern Higgins Ridge, like almost to the border of SPI land upstream. And so we had crews from the California Conservation Corps, who've also supported the project through a grant that funded a lot of their time, which was amazing to have. Crews from the Big Chico Creek Ecological Reserve, of course. We had the cultural monitoring crew from the Churchill Indian tribe, whose ancestral territory that is. So a cultural monitor was accompanying every crew to make sure that the rocks they turned over weren't cultural artifacts, and that cultural resources were protected during this whole time. Then we also had a 4-person forestry crew from Moortown Rancheria, who are expert tree fallers as well, who were accompanying one of the crews. So big team effort. This is our timeline. We just wanted to, for those who are interested in how this came together, the takeaway here really is that the park fire burned through this whole area in one day on July 26th. We went to work pretty much as quickly as pretty much as soon as anyone knew what had happened, to convene this incident management team along with our partners. And big shout out to Eli Goodsill, the director of the reserve, who really directed a lot of this vision as well. And then the upshot of all that permitting that I was talking about, and I think I'm done talking about now, is that we managed to start getting the first structures built. And the Big Chico Creek Ecological Reserve crew, convened all these crews into the canyon on September 30th. And we were really fortunate to have help from a couple of professional process-based restoration contractors that the RCD has worked with in the past. So Symbiotic Restoration, which has worked on process-based restoration projects that we've spearheaded in the upper watershed of Butte Creek, or that the Forest Service has spearheaded as well. And then Streamwise Restoration. Those are two really knowledgeable contractors who've built between them thousands, maybe tens of thousands of structures. I don't know. So it was great to have them in the canyon kind of validating the vision that all the other partners had and adjusting it as need be and saying like, well, what about this? Well, maybe you want to step away from that idea and focus on this. And they were also there to train all of these crew members, most of whom had never built a process-based restoration structure before, with some exceptions. So with that good training under their belts, we had them working for maybe 7 good weeks before the first major rain event, which was, as you recall, just before Thanksgiving, like November 19th and 20th. And in that time, they probably built the first 1,200 structures. So when we added up all those sites that were in feasible locations where we could install a structure that we thought would do some ecological or groundwater recharge good, and also potentially impinged on infrastructure so it qualified for our emergency permits, we had permits to install almost 7,000 structures. And we had no idea how many we would get to. We thought it wasn't out of the question to build that many. It all depends on how much it rains, right? And the crews managed to build 1,783 structures between September 30th and they stopped on January 10th. Of course, they took breaks in there during the big storms, allowed the storms to move through, move sediment around like rain is supposed to do, allow the structures to do their work. And then when it dried out a little bit, the crews were able to move back in and assess what had taken place and either maintain structures or sometimes adapt, pivot strategies a little bit, or just keep on building new structures and drainages that hadn't had the chance to get them yet. So this is what the existing map of structures now, as built, looks like. Looks like we've got a video here of runoff actually moving through some structures. You can see these hand-built rock structures. These structures were built using a mix of heavy machinery and then touch up by hand crews coming in and kind of perfecting that work. Let's watch it again. Once it's not enough. These tributaries have some boulders in them already that crews will use as anchor points. You can see some of those structures are constructed in kind of a subtle V shape. So we found that it was most effective when you want the structure to be built such that the center is a little bit lower than the sides. So the water can just pour nicely over the middle of the lip, like the lip of a pitcher. And as it does so, it slows down and it deposits the load of sediment that it's carrying. Another video of water looking clearer than you would otherwise expect. You can see, this This is November 21st. And I mean, it's really the first significant rain event of the season, other than that freak event in August. And you can see that those trees are resprouting really vigorously. They were resprouting vigorously in August. So those trees definitely have access to groundwater that's stored in the canyon walls that they were able to draw on immediately after the fire burned through. Got some pictures of what the canyon looked like a couple weeks ago. On your left, you can see, you're looking up a tributary, you can see a bunch of structures that were installed, one after the other, like Faith was talking about. So it's best practices to install a process-based restoration structure, usually about one structure per 1 foot of fall. And that redundancy that she was talking about is really helpful for capturing the maximum sediment and also ensuring that, you know, inevitably somewhere some structure is going to blow out, and then the others can kind of mitigate the damage from that and kind of hold everything in place. And it seems to be working overall generally pretty well. On the top there, you can see a bank of sediment, like a sort of a new sandbar that was deposited probably in the November storms, and it's already covered with California mugwort or moonmoony, some Indian lettuce, and some cool like mosses and algae that are moving in. On the bottom, you can see some sediment that was probably just deposited a few weeks ago, a fresh bed of sediment that will be colonized by rushes and other riparian plants very quickly. In the middle, we have a little fritillaria plant. It's growing in completely burned, you know, canyon soil, but there are so many of these geophytes in the canyon, these plants that arise each spring from tiny underground tubers or corms, and then you don't see them the rest of the year after summer. There's so many of these different geophytes that they come back in the canyon very quickly. And this fritillaria here, we don't know. I mean, I didn't dig it up to count the bulblets, but it's possible that this individual is many decades old and has seen many fires come through. So we've had a chance to get out there in the field a little bit now and see how some of these structures worked. We have not revisited every structure that was built. I'm sure nobody has gone back to every structure that was built. But it's really interesting to see the results. So where we didn't build any structures, we definitely saw what we expected to happen, which is that existing streams just got more deeply downcut. The quantity of runoff after these recent storms is just kind of hard to fathom. We know that after a severe fire like this, a 1 or 2 year storm can easily, in terms of precipitation, a 1 or 2 year storm can easily function like a 50-year storm in terms of flooding, because there's just nothing to hold that water, to hold the ground in place, like Faith was talking about. And also there's not as many straws in the system, you know, sucking up water. So the scene for runoff is just really set there. So yeah, huge torrents of water were flowing down streams. Where we did build structures, they filled up in almost the first storm. Most of them were pretty full after the November storm. We didn't expect that to happen. We expected it to take at least kind of the whole rainy season for the runoff to drop enough sediment to fill up all those basins that we had created, but it happened very, very quickly. Once the basins are full, water is of course just running over the top of them. And we saw some streams kind of use that opportunity to leave their banks. But sometimes when they did so, what resulted is that they just the water really just spread out over the land and kind of acted as sheet flow. And by then, also there was vegetation in place, because after a few rains, you saw how the land had greened up a little bit in some of those past pictures. So we just saw, in some cases, these beautiful waves and bars of sediment just deposited on the uplands. which we think is probably a positive outcome. And in other cases, streams are creating some new channels or new side channels before they return to their main channels. And we think that that can be a positive in some cases too. It's kind of too early to tell in every single case whether the result of this structure or that structure is something that we want to keep in the future or something that we want to adjust with maintenance. But we know that the Big Chico Creek Ecological Reserve teams are walking these tributaries now, probably as we speak. Well, maybe not today, but on the other hand, maybe they are. Today would actually be a really good day to go out there and see how they're functioning in this rain. And if the structures need maintenance or the stream channels need maintenance, we know they'll be seeing to it.
So as Wolfy was talking about earlier, this project took a lot of coordination and collaboration. And so these are just some of the partners who helped us a lot on this project. We have agencies and organizations and contractors, and all of these people really made this project possible. And then of course, the financial support as well from Sierra Nevada Brewery, CSU Chico. We got some Prop 68 funds from the California Conservation Corps, as well as the Vina Groundwater Sustainability Agency funds, and then some other generous small donors to BSER. And so with all of this support, we've been able to capture nearly 60,000 cubic feet of sediment to date.
That's $8.50 per cubic foot.
Yep. And I think it's a good time to just open it up to questions now, or if you have anything else to add, Wolfie.
Well, I've talked long enough.
Also, our contact information is here, so if you have something else come up later, feel free to reach out to us.
Yeah, thank you so much. I mean, this is really incredible work and amazing how many structures the team was able to build in such a short time and really respond to the winter that we got. You know, you never really know what storms and winter is going to bring. And so, yeah, this is really terrific. I want to open it up to anyone on Zoom that has a question for Faith or Wolfie. If you raise your hand, you can indicate that by raising your hand down at the bottom. There should probably on the bottom or where your menu is. And we can unmute you, or you're welcome to type your question in the chat and we can look for those there as well. Any questions? Well, people are thinking about it. Autumn, help me. Oh, I saw one hand raised. Yeah, Kelly. Let's see,
Hey, I just want to let you guys know that the chat seems to be disabled, so folks might be having a hard time typing stuff in. But
okay, good to know.
Just wanted to let you know that this was an awesome presentation too, and appreciate all the work that went into it and all the partnerships. So thanks.
Okay, great. Yeah, so chat is
Thanks, Kelly.
disabled, but oh, go ahead.
Well, I do see that Q&A is on. And there's a question here. Zach Owens asks, did you construct any sediment traps to accompany the beaver dam analogs / weir structures? I'm not really sure what you mean by sediment traps, except that the structures were always constructed at locations such that there was there's a little basin behind them where the sediment would settle out. And as we went through and we GPSed the location of every structure, we had people estimate the volume of that empty basin. That's how we're able to estimate how much sediment was captured when those all filled up. Does that answer your question, Zach? They're just large depression pits, normally upstream of the weirs, BDAs, much larger than a typical pool would be. But we didn't excavate the stream bed. So we just, by constructing the structures, we took advantage of the natural kind of pool and drop topography of these tributaries and just took advantage of the natural pools that these streams already had in them. Now, some of these tributaries are already pretty incised. So when I say natural pool, that makes it sound like something that's really beneficial that you would want to leave in a stream. But in some cases, these, what I'm calling pools, are actually like already pretty deep pits because the tributaries have been, down cut in a way that's not ideal. Bill Loker writes, has any soil testing been done on the sediment accumulating from winter rain deposition and how this might influence vegetation restoration? The sediment that has accumulated behind the structures has not, to my knowledge, been tested for anything. That said, in the area where we're working with, for the most part, there is nothing uphill from these tributaries that burned that might have released any toxins or elements of concern. So it's true some structures did burn in the canyon, but for the most part, not close to these tributaries. They were also, you know, surrounded with those toxin absorbing wattles and the things that Cal OES will put around a burn structure before the rains began. So we would expect that the composition of the sediment trapped behind the structures is the same as the composition of the sediment just on the hill slope on the uplands of the canyon. Will there or could there be a visit set up for the public to see the weirs? Well, there could be. Sooner or later, the Big Chico Creek Ecological Reserve and Upper Park, for that matter, are going to reopen to the public, and then you'll be able to see them. They're right there in the creeks. So I know, for instance, Bidwell Park just finished or is in the process of finishing the hazard tree removal along 10 Mile House Road. And when that happens, Upper Park will be reopened to the public. So by going down 10 Mile House Road, again, once it's open and safe, and turning upstream, you'll walk past multiple tributaries that have these weirs in them, and you'll see them. They're stacks of logs and rock. Yeah.
Yeah, that's great information. It's helpful to know kind of how to get there even. Yeah. We'll see if there's any others. Again, you can raise your hand or yeah, go ahead and type your question in the question answer. While we're waiting, I was gonna ask you, so having done this kind of through, you know, emergency, obviously response, what do you think about this type of approach kind of in a non-emergency situation in other parts of the county or in these kind of tributary or even across the lower foothill areas, right? Where there's kind of been grazing land.
Yeah, that's a great question. I see a lot of potential for it. I think I would have liked to, it was kind of just a quirk of like funding and landowner enthusiasm that we confined this project to the Big Chico Creek Canyon. I would have loved to see us also be able to install these structures on like more subtle drainages on rangeland. I think there's a lot of places where over the years streams may have been downcut or kind of gullies may have been downcut, that there's so much potential to grade again using these types of structures. And that first year, or sometimes the first couple of years after a fire, are in a way such a gift when sediment is mobilized in these rainy seasons like it's not mobilized any other time. So right after a fire, if you are able to install a process-based restoration structure right away, then you get this pulse of sediment that, like, you know, you as a meadow restoration practitioner, you know, you would just pray for. Like, sediment is like gold. So I can like just walking around the rangelands of Butte County or Tehama County where I used to live, there are so many streams that have been downcut so badly, and it would be amazing if a pulse of sediment would just come from upstream and meet with an obstacle and regrade those streams and hold that sediment in place. So yeah, I'd like to see this done a lot more. I think there's a lot of opportunity for it, and I think there's also a lot of benefit to be derived both, in down-cut tributaries and also in places you might not even really think of as tributaries, places that are more like ephemeral washes or draws. They can still transport a lot of water, maybe once a year, once every 2 years. And there's probably some recharge potential there. And I think to get the most out of it, you probably need to look at underlying geology and stuff like that. But if floodplain and aquifer recharge works on a grand scale, I think it probably works on a micro scale too. I think I think we're just starting to scratch the surface of understanding this kind of, it's funny to call it technology, it's just stacking rocks, but understand the potential of these types of actions. And I'm sure that, we installed some structures that, like, if we looked back 5 years from now, we'd look back and say, like, I can't believe we put that structure there. That was so dumb. And I think there'll probably be some other ones that we are feeling really, really good about.
I think I would just add to the thought about rangeland too. I think there's really incredible opportunities there as long as you're pairing it with exclusionary fencing.
Yeah.
And as long as you really know that if you're going to put these structures in, especially if you're doing more like beaver dam analogs, that you're going to be re-wetting, you're gonna take that water and push it out, and then you're gonna have really soft soil. So if you do have grazing still happening in that area, then your banks are, I mean, it's already at risk, but then it's really vulnerable. You have that really soft soil. So I think putting in the structures and then fencing it off from grazing would be the way to go on that one.
Yeah, for sure. And that can really be a win for ranchers too, because you have, once you fence off those riparian areas, you just have the opportunity to essentially you can move your cattle around, or we're saying cattle, you can move your livestock around by transporting water really wherever you want. And then you can get so much more benefit out of the impact of livestock on your land by managing them more actively. So I think there's a lot of potential there too. Faith makes a really good point that if you're going to change the way that water flows or is retained over your land, you're going to change your vegetation patterns too. And so you'd want to plan for that.
Yeah, makes sense. Okay, we have a couple new questions there. Do you want to check out?
Has anyone developed estimates of the overall increased sediment load to Big Chico Creek thus far from the park fire? I don't know. I think that the WERT team could probably, so WERT is Watershed Emergency Response Team. That's the group of scientists and engineers who convene after a big fire and make estimates of the threats, especially around erosion and landslide on non-federally owned lands. I think they have the tools to calculate something like that. The water board or DWR may be calculating something like that. I guess I don't really know of an estimate like that. Do you, Faith?
I don't know.
But the practical limit of these measures to make a dent in sediment load is the volume of the sediment basins behind the structures. So Zach pointed out, we could have constructed deeper sediment traps. We didn't choose to go into the creeks and construct bigger basins. We just used the existing topology there. So yeah, like I was saying, they filled up much quicker than we thought.
Yeah, and I think that's something we always try to mention is that although we put in a lot of structures and they filled up rather quickly and they captured a lot of sediment, we couldn't put structures everywhere. And so it's improving the water quality, but of course we're still seeing sediment in the creeks. And so that's just something we have to live with.
Yeah. Yeah, the creeks were still brown all winter, right? And they're probably running brown right now too. Even as vegetation fills back in, and runoff isn't as drastic anymore. Hopefully with this storm compared to what it was with the November storm. But yeah, if we define success as keeping sediment out of the creek, we would have been an abject failure. But what we did do though was keep some sediment on the hill. So that has benefits for vegetation communities, for the wildlife that use springs and seeps. And we think over time it has benefits for the aquifer too. Bill Loker asks, How can the public get involved or contribute to ongoing restoration activities in the Big Chico Creek watershed, particularly Upper Park, but also Lindo Channel, etc.? That's a great question. So there's a few opportunities to stay abreast of what's going on in the Big Chico Creek watershed. So you may already, but if you don't, I would definitely consider following Big Chico Creek Ecological Reserve on social media. They may have a newsletter. I'm not sure. I just follow them on social media, and I talk to them all the time. You can attend Bidwell Park and Playground Commission meetings and hear more about what long-term plans are for the park and other city-owned lands. I guess those would be my big ones.
Yeah, I think those are the big ones. And then for the Lindo channel, I think getting involved with the weekly tech workshops.
That's a good idea.
With Ali Metter's Night. They do a lot of work in Verbena Fields, and I've gone out there before and built willow wattles to help with erosion. So I think that could be another good opportunity. I think it's weekly.
Yeah, you might enjoy that. Yeah, I think I don't remember what time of the week they're meeting
I want to
lately.
say it was Friday mornings or Thursday mornings for a while.
Yeah, it's sort of a community volunteer effort to care specifically for Verbena Fields, which is right on Lindo Channel. And Verbena Fields is, as you know, it was sort of constructed as a big settling basin or component of the hydrological engineering that accompanies Lindo Channel. So just standing there and walking around really gives you a new perspective on how floodwaters move through Chico. Oh, Bill says they're on Friday mornings. There you go.
Yeah. What was that group called again? What was it?
People
You
just
know?
sort of call it the TEK group, TEK being standing for traditional ecological knowledge.
Okay.
It's convened by primarily by Ali Metter's Night, or at least that's who I associate it with. Yeah.
Great. Yeah. So you had mentioned that BSER folks have been out and about and keeping an eye on the structures, and what's kind of the long term? I know that they're long term on that land, right? But is there kind of a monitoring plan going forward, or what are the next steps, to understand how these play out over time?
Yeah, I don't know that there's a formal monitoring plan, but there's definitely monitoring going on every day as the crews move up and down the canyon. Their next stage there is really to focus on their roads and crossings. So a big objective of this whole process-based restoration effort was to spare the roads from as much compromise from high flows as we could. And the roads still really took a beating. There's a lot of historic roads out there that maybe were built with undersized culverts, or even culverts that were of a reasonable size before the fire. Now the way the hydrology works in the canyon is so different after the fire. They really need to be resized to accommodate larger flows. And that's not just the Big Chico Creek Ecological Reserve, it's almost everyone who lives in a canyon after a fire deals with the same problem. So I know that the reserve is, and rightly so, focusing on their road network and making like an inventory of sites that are highest priority for improvement, which is something that any landowner should be doing after a fire. It's not, you can work, if you own land that was recently burned and you're seeing impacts to your roads or your tributaries that aren't acceptable to you, you should consider consulting with a hydrologist who can, you don't need to, consult with a full-on engineer, but a hydrologist can just calculate the correct size of culvert or the correct type of crossing. Sometimes the answer is actually to pull out a culvert and make your crossing into a different kind of something that's not a culvert. I'm not thinking of the words, but a different kind of crossing.
Yeah.
And anyway, it's really important though, that those culverts or crossings be correctly designed and correctly sized for the size of the basin that they're draining. And that's something that we can't really just do by ourselves. You need some special skills for that.
Yeah, that's helpful. I think post-fire, just all the different implications, right? And things that change. Yeah, thanks, Patricia. Put the techchico.org in the question answer. So if you're looking for more information on that, there's a link there. Any other questions from folks? Looks like maybe not. Thank you so much for describing the work, for your leadership in this effort, and for telling the story kind of what was able to be done and what's next. And I think it'll be great to keep in touch and look for opportunities, to continue this type of work across the county and post-fire as well. Any final?
Thank you for having us. And no, just thanks for having us here, and thanks for funding this pilot project.
Yeah, absolutely. It was a honor, really, and pleasure to be just a small part of the team that helped make it happen, and great to use kind of the work that Vina GSA is doing and the county, our department is doing to help understand work in the higher watershed areas and how that connects down to what aquifer and groundwater understanding is happening more in the valley. So yeah, I appreciate it. All right, thanks all. We will post the recording of this, and so we'll make sure to send out the link to that once it's available. And again, I want to plug the March 25th panel for recharge water supply and conservation efforts. So if you're interested in hearing more about what those projects are doing and asking questions kind of in one place, that is going to be a great opportunity for that. That'll be in person in Chico, and look for more details to come out soon via email and social media. So thanks all, really appreciate it. Thank you again, Faith and Wolfy, for your time and your expertise on all of this good work. Take care.